And I'm just so excited that you guys are here, as we are celebrating the launch of Artemis 1. Artemis 1. Artemis 1 is basically will be the first in a series of increasingly complex missions that will enable us to explore the moon, Mars, and beyond. So, and Artemis 1 is set to launch this year, 2022. And again, we're going to talk more about that and then the future missions of that. Welcome again. My name is Latina Taylor. I'm a NASA EPDC education specialist with NASA's Educator Professional Development Collaborative over at Texas State University. And again, so excited that we have our students aboard as we get ready to explore and have some fun. And so the first thing I want to ask, because I don't want to, assume anything from you students, I want to know some things. And the first thing I want to know is, what do you know about NASA? What do you know about NASA? I want you to think about that question for a minute. As you're thinking about that question, I have a way that I would like for us to share and document our learning. We're going to be using something called Padlet. Remember, I want you to think about what do you know about NASA? Padlet is actually an awesome tool. It's very user friendly, where it has you to basically, for us, document our learning along the way. You can post images, you can collaborate online, text, videos, voice, so much more. But for us, we're going to text. Okay, and the first box here, or the post, is what do you know about NASA? Now, all you have to do is literally click on that link. And once you click on that link, you're going to look for, you see the NASA meatball, and then you're going to click where it says add comment. And I want you guys to go ahead and think about, what do you know about NASA? And I would love to take a look at some of your responses. You can, if you can't access the Padlet, you can also put it in the chat box as well. Okay, so let's take a look. Someone says, okay, this is Spanish, so I'm going to do my best to read it in Spanish. It says NASA studies relations with the planets. I believe that's what it says. And I think I translated pretty good. So thank you. Yes, NASA does study relationships with all of our planets, with our planets in our solar system and beyond. We send amazing spacecrafts, and I want to talk about one in particular, the Cassini spacecraft that has been studying Saturn for many years and has been bringing back amazing images and research to let us know, the makeup of Saturn and things like that. So for sure, yes, NASA does study that. Do we have any more ideas about, what do you know about NASA? That was amazing. So thank you for your participation with that. Let's continue to look to see if we have any others. Okay. All right. So I'm going to go ahead. So thank you for taking a moment to, think about, what do you know about NASA? A little bit, if you don't know, even know the acronym is National Aeronautics and Space Administration. So it is the U.S. government agency that's responsible for air and space technology. And so we're going to get into that, especially the space part. Okay. So before we do that, we're going to time travel. Let's time travel, guys. We're going to go back to a very important date in our history. And this date is July 20th, 1969. And on this day, or the day after, actually, you can see all the headlines of the important event that happened in newspapers all across our country on this historic day. Newspapers, students, was, the internet back in the day, okay? So we had newspapers, physical papers that we read. You can see the news feeds, and the headline is literally the top story of the day. And in this case, you can see some of the things that happened. They did it. Giant leap for mankind. Man walks to the moon. So as we go back in time, on July 20th, 1969, Commander Neil Armstrong, along with Command Module pilot Michael Collins and Lunar Module pilot Edwin Buzz Aldrin, yeah, those three, took a small step for man and a giant leap for mankind when they walked on the moon. The primary objective of the Apollo missions back in the day were to complete a national goal that was set by President John F. Kennedy in May of 1961. And the goal was this: perform a crewed lunar landing and return home safely. Okay. And I want you to know that an estimated 650 million people watched Armstrong's televised image and heard his voice as he described, the event. And so this link here, ladies and gentlemen, is a sound file to that link. But I'm going to do you even a little bit better. I'm going to take us, we're still back in time. I'm going to take a look at that moment, at that televised moment. Now, remember, boys and girls, this is, some old footage, so it's going to be a little blurry, but you can still hear those infamous words. So let's take a look. Let's give it a second to get to here we go. I'm going to mute myself.
Fine grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the limb. That's one small step for man, one giant leap for mankind. Oh, that looks beautiful from here, Neil. It has a stark beauty all its own. It's
Now, Back to the Future. It gives me goosebumps just to even think about that, right? Think about that moment, that historical moment that happened in 1969. I was going back and taking a look at the Padlet. Thank you guys. So someone said what they knew about NASA is that NASA sent the first man to the moon. Yeah, and we literally just saw that. And so now let's go back to the future. So with the future, or right now, did you know that we're going back to the moon? Yeah, we're going back to the moon. Let's check out the spacecraft and the rocket that will get us there. Meet Orion. Yeah, Orion. For the first time in a generation, NASA has built a human spacecraft designed for deep space exploration. And it was named after one of the largest constellations in the night sky. And it's drawing from more than 50 years of research, of space flight research and development. Let me tell you about this. Orion will serve as the exploration vehicle that will, 1, carry the crew to space, 2, provide emergency abort capability, just in case something happens, and 3, sustain astronauts during their missions and provide that safe re-entry, coming back home safely. That's what we want. We want our astronauts to come back home safely. Let me tell you a little bit about the Orion capsule or the module. This module is designed to accommodate 99% of the human population, which is a huge range. I want you to think about this. This spacecraft can accommodate astronauts as small as a 4'10" female or as tall as a 6'5" male. Okay. And this module actually provides 30% more cubic volume space than the Apollo capsules. Okay. Take a look at this. This is the world's largest heat shield. It's beautiful. It measures 16.5 feet in diameter and it has been successfully attached to the Orion spacecraft. It's ready. This heat shield is made from one single piece of a material called avocate ablator, which was built by a company called Lockheed Martin. And this material is actually designed to burn away rather than transfer that energy, that heat energy, back into Orion. I'm going to give you an interesting fact. Standing between that crew module and all that heat is no more than 1.6 inches of that avocate material. Yeah, 1.6 inches. So some 20% of that avocate will actually erode during the spacecraft's return journey back to Earth. This heat shield can stand temperatures of about 5,000 degrees Fahrenheit. Okay, now I know you're like, what? 5,000 degrees Fahrenheit? How hot is that? Okay, let me give you this. 5,000 degrees Fahrenheit is half the temperature of the sun. Okay, so it can stand pretty hot. And so, upon re-entry, what happens is Orion pushes air particles out of its way, and those particles heat up. And the temperatures around the vehicle can reach about 4,000 degrees Fahrenheit or even higher. And so during re-entry, Orion is literally a ball of fire. Yeah. And so, this return entry, it's coming in as faster than a speeding bullet, okay, at about 25,000 miles per hour, which is fast, very fast. So I want you to think about if you're in the cars, with your parents, students, the average speed is probably about what, 60, 55, 70. And you're thinking, oh, mom, you're going so fast. But we're talking 25,000 miles per hour. So it's coming in very fast. And so Orion has specially designed parachute system, that will basically help to slow it down, to a gentle pace, because we want to keep those astronauts comfortable, as they're coming down for that splashdown in the ocean, where the Navy will pick them up and bring them back to the Kennedy Space Center, for more, inspection and cleanup and so forth. And so that's Orion. Meet SLS. SLS is the Space Launch System. This is the most powerful rocket in the whole world, literally the whole world. Artemis missions will launch from NASA's new modernized spaceport over at Kennedy Space Center on the agency's new heavy lift SLS rocket, Space Launch System, and it is also designed for deep space missions. And it's going to pave the way, for flights for astronauts, and our first tests of the rocket and Orion will be this year, 2022. How cool is that? Having difficulty with sound. Okay, so the only thing I can say is to log out and log back in. Is everybody having difficulty with sound? Because my sound is on, the camera is on. I'm wondering if I need to pause my camera. You can hear Latina? Okay, thank you, Dr. White. Thank you. So maybe those that are having some difficulties, the only thing I can say is to log out and log back in. If the difficulty persists, after you come, maybe I'll turn off the camera, and maybe the camera could be, the issue. Thank you guys. Thank you for giving me the feedback. A little bit more about SLS. SLS, take a look at it. First of all, it's beautiful. It has 4 main sections. First of all, it stands nearly 400 feet tall. The upper stage, that's where Orion sits. So right up at the top, that's where Orion sits, and will carry 4 astronauts to the moon and bring them back home safely. And then you have that orange area, that's the core stage. Well, guess what? That holds about 733,000 gallons of propellant. That's a lot. Enough to power the 4 RS-25 engines that, for 8 minutes, sending the rocket soaring at 17,000 miles per hour. That's incredible, right? And those two white solid rocket boosters, they stand about 17 stories high, and they generate 3.6 million pounds of thrust. That's a lot of power. And those engines that I spoke of, those are at the bottom, or right underneath the core stage. So I have a big question for you. How do you think that NASA communicates with faraway spacecraft? As we're going to the moon, how are we keeping in touch? We need to know what's going on. What's happening? What is happening? I want you to think about that. I want you to think about that question. And then I want you to post your ideas. I want you to post your ideas on how do you think NASA communicates with its spacecraft in our Padlet. So we're going to look at this time, we're going to look at the Padlet post with the antenna dish. So if you can see that where it says, how do you think NASA communicates? I want you to add your comments underneath the big white antenna where it says add comment. And I'm going to take a look at some of the posts right now to see, what do you guys think? How do you think that NASA communicates with its spacecraft? So let's see. Someone says radio communications. Okay. Someone says using deep telescopes. Wow. In the chat box, someone says, I think someone says maybe that means radar instead of LiDAR. I'm not sure what LiDAR is. Satellites. So thank you. Thank you. Okay, thank you. I'm so glad that you can hear. I'm so glad everybody can hear. I just want to say that. I'm so glad that the sound is working. So someone says by using deep space telescopes. Wow. And then Amy says using effective telecommunication techniques. You guys are awesome. These are some really great ideas. So I love that you're thinking this through. Not later. Oh, lasers. Okay, lasers are used in LiDAR. Gotcha. Thank you, Imani. Thank you so much. And so, so these are some of your ideas. So let's take a look and let's talk about this a little bit more. So, spacecraft send communication and pictures back to Earth using NASA's Deep Space Network, which is a big collection of radio antennas. Okay. The antennas also receive details about where the spacecrafts are, like where they are, and how they're doing, and what's going on. NASA also uses the Deep Space Network to send a list of instructions to the spacecraft. And so, the Deep Space Network has three big antenna. There are three big antenna complexes that are evenly spaced around the world. There's one in California, there's one in Spain, and the other is in Australia. And so, so what happens is as the world is turning, and we're turning and we're rotating, the antennas are moving, and they are always in contact with the spacecraft, no matter where they are in the sky. So we don't lose that communication. These three, the Deep Space Network consists of these three facilities, and they're spaced in equal distance of each other, which is approximately 120 degrees apart in longitude, all around the world. And so this strategic placement, helps to have this persistent communication with the spacecraft as our planet rotates. Okay. And when you're talking about making a long distance call, it's hard to top NASA's Deep Space Network. It is the largest, most sensitive scientific telecommunication systems in the world. Okay. And it provides radar and radio astronomy observations to improve our understanding of the solar system and the larger universe. And it's operated by NASA's Jet Propulsion Laboratory, over in Pasadena, California, which also operates many of our agency's interplanetary robotic space missions. Okay. And I want to tell you, let's talk a little bit about telerobotics. Take a look at that word, telerobotics. Telerobotics is a special right from home. Other planets are studied, and I talked about the Cassini um, robotic satellite here. This spacecraft is in orbit of Saturn, and has been sending information to us about Saturn for many years. Both rovers and satellites have computers on board that are able to receive and execute commands right here from home. Let's take a look. This is a really great video of how we communicate with faraway spacecrafts.
How do scientists and engineers communicate with faraway robotic spacecraft exploring our solar system? When scientists and engineers want to send commands to a spacecraft, they turn to the Deep Space Network, NASA's international array of giant radio antennas used to communicate with spacecraft at the moon and beyond. Operators at the Deep Space Network take commands, break them into digital bits, precisely aim these big antennas at the spacecraft, and send those commands to the spacecraft using radio waves. But what are radio waves really? Well, to start with, you probably already know they're part of the electromagnetic spectrum, which includes other kinds of waves and light that you're familiar with. Electromagnetic energy is a type of energy that can travel through space as waves that have different properties, depending on the size and spacing of the waves. These waves span a broad spectrum, from very long radio waves to very short gamma rays. The human eye can detect only a small portion of this spectrum, which is why it's called visible light. Radio waves are the longest in the electromagnetic spectrum, and the wavelengths used by the Deep Space Network currently range from about the size of a dime to the size of a dollar bill. Radio waves are all around us. We use them when we listen to music over the radio, or send emails from computers using Wi-Fi, or when we talk on cell phones. Computers and cell phones are actually just high-tech radios. Radio waves also travel really, really fast, at the speed of light. That's 186,000 miles per second. But our solar system is also really, really big. It could take several minutes or even hours for the radio waves to reach a spacecraft. Once spacecraft receive the signal, they execute commands, collect scientific data and never-before-seen images, and send all of that data back to Earth as digital bits, which are gathered by the huge antennas of the Deep Space Network and distributed to scientists, allowing them to learn a little bit more about how our solar system works. To learn more about the Deep Space Network, visit go.nasa.gov/about-DSN.
Okay, I'm going to leave the camera off for a moment because I'm hearing that it froze, and so I'll just leave it off for a moment, and I'll come back to it when we discuss your activity, your challenge. So, as I spoke of earlier, we're going back to the moon. We're going back to the moon. Yes, we are going. We're going back to the moon with a program, with a mission called Artemis. Artemis is an ongoing space mission currently run by NASA with the goal of landing the first female astronaut and the next astronaut of color on the moon's south pole by the end of this decade. If you know a little bit about Greek mythology, Artemis, is the twin sister of Apollo. Apollo, we had the Apollo missions back in the day, and Apollo was the sun god. Well, Artemis, his twin sister, is the goddess of the moon. And how fitting is that? She's also the goddess of hunt. So these Artemis missions, this is the torch bringing, personifying our pathway to the moon. And so during this next era of human exploration, we will discover life-saving, earth-changing science and innovative technologies along the way. Artemis, is NASA's first crewed mission to the moon since Apollo 17, and that was in 1972. Yeah, and so NASA intends to launch future crew missions to Mars. And this whole moon to Mars plan, well, it involves building a brand new space station called the Gateway that will be in lunar orbit and eventually a habitable moon base. Yeah. And, Gateway, a little bit more about Gateway, the Gateway will be an outpost. Yeah. Orbiting the moon and providing that vital support that we will need for those long-term human missions to the lunar surface, as well as a staging point for deep space explorations. And and much like the International Space Station, which has been in operation for more than 20 years, the Gateway actually serves, as a model. A model that, it will be constructed with the help of our international partners. And several of which have already, have signed on and expressed, high interest in participating. We have the European Space Agency, Canada, Japan, all committing to join in the creation and the use of the Gateway. This is our trajectory or our map to the lunar surface. SLS and Orion, they are part of that larger lunar campaign, which is our first phase to get to the moon. And our first phase will be Artemis 1. Artemis 1 is set to launch 2022. This will be the first uncrewed mission. Uncrewed, that means no astronauts aboard. So this first test flight will be of NASA's Orion spacecraft, the Space Launch System rocket, and all the ground systems over at Kennedy Space Center in Cape Canaveral, Florida. And during this flight, the spacecraft will launch, on the most powerful rocket in the world, and then fly further than any other spacecraft has ever done, traveling over 280,000 miles from Earth. Take a look at this image here. This kind of gives us the trajectory. So after one orbit around the Earth, Orion will fly through Van Allen radiation belts. This is where it will experience high amounts of radiation. And it will take about 4 days for Orion to get to the moon. And so the spacecraft, again, will then fly the furthest it has ever gone, 40,000 miles beyond the moon, further than we did with Apollo. And then spend about 6 days in that vicinity of the moon before beginning its 4-day return back to Earth. Engineers test. And so this is what we're going to do. We're going to test. A part of the engineering design process is testing, making sure it's working, finding out what's working, what's not working, before we put our astronauts aboard. So that is Artemis 1. And that is, what's the exciting part again? That this is set to begin this year, Artemis 1, 2022. So that's why we celebrate this. And then we're going to talk about future missions. But before we talk about the future missions, I have a question for you. My question is, what do you want to know? What do you want to know about Artemis future missions? So I want you to take a look at our Padlet. Take a look at our Padlet, and I want you to look for that A for Artemis. Look for that A for Artemis, our Artemis column. And I want you to give me some questions. I would love to know, or, thoughts. What do you want to know about the Artemis future missions? If you can't access the Padlet, you can easily put your ideas in the chat box. Okay, so I'm going to take a look at the Padlet. I want to see some of the things of what you want to know. What do you want to know about the future missions, Artemis future missions? Go ahead and take a moment and put those ideas again, either in the chat box or in the Padlet. Okay, I'm taking a look and see. I'm going to take a look at a couple of questions from last night. One question that I can see, and this is from Amy Feingold. She says, will people be able to live, work, and enjoy entertainment at the station? Maybe she's talking about the Gateway. You know, we're going to find out more about the Gateway. The Gateway definitely be an outpost, right? So it'll be our bridge to ensuring that we can, land safely on the moon and come back. So definitely will be where we can have our supplies and things like that. So I'm sure they'll be able to put some enjoyment into that time there. It says Artemis 1 will send robotic women. Or he says, will Artemis 1 send robotic women before sending real humans? That is a great one to know. So, actually, we are sending a robot set to launch or set to arrive on the moon in 2023. Viper. Viper, let me tell you about Viper. Viper is a special kind of robot. Viper will go to the south pole of the moon, where NASA has discovered that the water molecule H2O is prevalent there, water ice. And so Viper, this robot, will go to the moon and begin to search for the moon's water and create a map of where all the water is, and then send that map back to us so that when we do get to the moon, we'll be able to know where that water is, because, hey, it is a resource that we definitely need. But we'll talk more about that. Okay, that's fine. If you can't find the option, you can write your thoughts right here in the chat box. Ashiki, I hope I said your name right. Santra, you can put your thoughts right here in the chat box. So let's go on. Let's move on. Let's find out about future missions. So we know about Artemis 1, right? That's our test to make sure that everything's working right. Artemis 2. Yes, Artemis 2. This will be a crewed flyby, okay? Astronauts will be aboard. For the first humans to the moon in the 21st century, right? In our lifetime, aboard SLS rocket and the Orion spacecraft. On this 10-day crewed test flight, NASA astronauts will set a record. Yeah, they're going to set a record for the furthest human travel from Earth. Yeah. And so with up to 4 astronauts in tow, we will return to the lunar environment for the first time in over 50 years, literally 50 years. This will be, the Artemis generation's Apollo 8 moment. When the astronauts will have a backdrop of the Earth as a globe, as a huge globe, and they'll be able to see it, from afar in this distance, while the moon is right there, with them. Now they're not going to land. They're going to do what we call a lunar flyby, right? And so this is just a really great, opportunity to test once again to make sure that all the equipment and everything is working safe and sound. So, while they're on board the Orion spacecraft, they will validate all of the deep space communications, making sure that we can communicate back home, right? That's so essential. And then all the navigation systems, and then assure that all the life support systems are working, and to help keep them healthy and safe. They're actually going to be using Orion's light control and shading systems to simulate nighttime. To ensure that there's, the proper circadian rhythm is happening during their missions. And so this is a picture of the astronauts training in the Orion mock-up over at the NASA Johnson Space Center in Houston, Texas. Take a look at our astronauts. Yeah, this is the initial group that will, pave the way for our missions to the moon, Mars, and beyond. And one of them will be the first woman astronaut and the first person of color that will, land on the moon. This is chosen from the most diverse group of astronauts in history, and they all bring a wide range of life experiences. We have medical doctors, marine biologists, submarine officers, test pilots, geologists. A big question for you students: why do you think we will need a medical doctor? Why do you think we'll need a medical doctor, aboard the Artemis missions, excuse me. Why do you think we will need a medical doctor? We'll love to hear you in the chat. We'll love to know, what are your thoughts, students? Why will we need a medical doctor? Why is this necessary? I'm going to let you type some thoughts in there as I'm seeing some typing going on. Why will we need a medical doctor, aboard the Artemis crew, or be a part of that Artemis crew? What is meant by the first person of color? The first person of color could be an African American. It could be a Hispanic person. That's meant by a person of color. Those are some examples of people of color. Thank you for your question, Ashiki. I hope I'm saying your name right. Santra. Muscle atrophy in zero space environment. Yeah, anything could happen, right? Anytime that we travel outside of our earth, which is our home, our natural environment, it is a hazard to us, right? It's a hazard to our bodies. We love our planet. We want to be here. So anytime that we're away, it is a risk. We have radiation that's coming in, astronauts have to literally exercise. They're required to exercise 2 to 3 hours a day, to keep their muscles up. Yes. So, anything could happen. So we definitely would need someone with medical experience to, help problem solve and help to make sure that we're healthy and in tip top shape, so to speak. Okay. And so Artemis 3, here we go. Now, with all the confidence that we've gained with Artemis 1 and Artemis 2, the Orion, SLS, and its crew will once again travel back to the moon, but this time, when they get to the moon, they're gonna board the human landing system that will bring the first woman astronaut and the first person of color to that moon surface, right? To that moon surface. And then I'm wondering, what will the first words of those astronauts be? Just like we had back in the day, we went time traveled and we listened to the first words, from the Apollo missions. This one small step for man, one giant leap for mankind. I'm wondering, what would our Artemis generation astronauts say when they set foot on the moon for the first time in the 21st century, right? And so the human landing system, this thing is amazing. 2 astronauts will board this and they will carry them to the South Pole with science tools and experiments and equipment. And then the 2 other astronauts will remain on Orion. And then, they have a goal to actually have up to about 4 moonwalks, study the moon, be there for about 6.5 days, and, we'll do science, make some discoveries, find the moon's water, and use it, the water molecule, H2O, hydrogen, oxygen, right? So we'll definitely, take that water and, first of all, we need to drink it. Secondly, or, purify it to drink it. And then hydrogen, for fuel, oxygen to breathe. So it's definitely a resource that we will be looking for and we will need. And then we will learn how to live and work on a whole nother celestial body, how to live and work on a moon, right? And to prepare us for missions abroad, right? And further, like Mars. And then here's the base camp. right? Take a look at this. Each Artemis mission, to the surface will help us test spacesuits, habitats, landers, rovers. And each time we visit, we're going to stay longer. Okay, we're going to stay long. We're going to be living and working on another world and help to prepare us for Mars. Um, you know, we're going to do something very different than the Apollo missions. If you take a look at that pressurized rover, it's built to, sustain, to live on there for at least 40 days, right? And you can eat there, sleep there, bathroom facilities, you can drive, and the whole goal is to explore more of the moon than we ever did before, right? And so, so that's what the future looks like. And everything that we do and everything that we learn during these Artemis missions and future missions will help pave the way for our human missions to Mars. And I want you to think about this, students. Think about this one. You in our classrooms today, okay? You are NASA's Artemis generation. We are the Artemis generation. You are our next generation of innovators, explorers, scientists, technologists, engineers, mathematicians. You're going to be able to bring all these ideas together and develop these new technologies that will help propel us to Mars and beyond. We're counting on you. Okay. Briefly talk about what radiolith. I don't even know what the word radiolith means. Thank you, Imani. I do not know what radiolith is or what it's composed of. That's something you can definitely email me and I can do some research on that. If this have to do with the moon, I'm not sure, but great question. I can't even talk about it. Thank you. Medical doctors, Ashaki, I hope I'm saying your name right, Santra. Medical doctors are needed to check the effect of the environment on the human body because we have to live their future. Yes. Thank you. Hello world, first words. Okay, first words could be hello world. Yes, it's definitely. I'm just going back and taking a look at the chat because I haven't been able to look at it. So thank you guys for your thoughts. Okay, the moon soil. Thank you for letting me know that. Okay, monitors astronauts help. Thank you, Sulini. I hope I'm saying your name correctly. And so here's just another little picture, an image. Going to Mars will not be easy. It will not be easy. At its closest, Mars is about 39 million miles away from Earth. Okay, so a round trip. It will take it's about 2,000 times as far as a round trip distance to the moon. And so, it'll literally take about 2 to 3 years for that round trip or one-way robotic missions going back and forth, which if we were, for example, to travel to Mars from here, from home, from Earth, it takes about 7 to 8 months, just in that travel alone. So I'm thinking about you guys, students, how will we survive? How will we have a capsule that could, accommodate us? How will we, have food and, things that we need for those 7 to 8 month travel to, Mars, just to get there, and so again, everything that we learn and these Artemis missions, and the Martian robots that are already there doing lots of work for us, will help pave the way to get us to Mars. And maybe, students, you will be one of the first astronauts on Mars. Okay, so that's a little bit more about our future missions. But I'm going to give you this video that's going to tell us how the plan to travel to the moon, Mars, and beyond. So give me a moment while I get that video up, and then we're going to go into the activity. Quick activity.
In the next 8 minutes, you'll experience a 25.5-day mission.
Actually, that's not the one. Hold on. Give me one moment. Actually, this is what I'm going to do. Because of our time, I'm going to put the video in link in the chat box. So I actually thought that was that video there, that's there. I'm going to show you about, I'm going to give you a little information about the video. That's about 8 minutes. It's a really, really great video that details, hold on. This is a video that you can take a look at. Hold on. This video here really details, it's an 8-minute video, and it details our exploration for Artemis 1, but us pushing further into deep space. And so definitely take a look at that video, and I'm going to put that in the chat box. But right now, I'm going to go ahead and move us to our activity. Give me a second while I put that second video into the chat box for you to take a look at. There we go. All right. Oh, before we get into that, would love to know what you have learned, okay? We've been talking about Artemis future missions. I would love to know, what have you guys learned? You know, you've gotten a lot of information just now about Artemis 1, Artemis 2, Artemis 3, and, you know, all of our, you know, our voyage, you know, to the moon and Mars and beyond. If you can take a moment and do a post in the Padlet. If you can't access the Padlet, that's okay. You can type right here. So look under the column where it says, what have you learned about Artemis future missions? And then add your comment there. I'm going to take a look at the Padlet just to see what ideas you guys have come up with. As I look, I'm looking at some ideas from last night. Many firsts, lots of technology and equipment tests to try everything out and refine for Mars. Yes, all about getting ready and learning everything we can as we voyage to Mars. Wonderful. Lots of deep space exploration and finding life on the moon. Okay, Amy, fine gold. And I think it says Bridget or Bridge Deep Space Network awaiting this year's launch. Yes, I'm awaiting this year's launch too. It's exciting. These are exciting times. Exciting times indeed. Okay, do we have any others? What you've learned about 1 minute? Okay, there will be 3 Artemis missions. Yes, thank you. There will be 3 Artemis missions to get us there. You know, we're not just going to go, you know, just all 4. We need to test things out. That's what engineers and scientists do. They test things out to make sure everything is working properly. Everything is how it should before we, you know, send our most precious astronauts, you know, aboard and to do those things. So thank you. I'm going to go ahead and continue. Okay. And so now it's all about communications, right? And networks. And I want you to, and one thing you're going to do is you're going to solve a variety of network problems using a method called spanning trees. So basically, you're going to determine the shortest route to visit a destination in a network of things, okay? Within a network. If you take a look at this, this is just an example of a minimal spanning tree. And basically it says a number of problems from graph theory are called minimal spanning tree problems. In graph theory, a tree is a way of connecting all of the vertices together so that there's exactly one path from one vertex to another. Okay, you can take a look at graph G, and then you can see the different spanning trees that come from graph G. This is just an example, and teachers, you can definitely elaborate more on this concept with students. Your challenge is that you're going to find the most efficient way of getting from one place to another in a network. And another thing, educators, you definitely want to check out the Career Corner here. This is, he was known as the father of the Deep Space Network. And so you definitely can click on that link and enjoy and have that STEM career connection with students. these are the materials. The biggest material that you will need for this first challenge, and I'm just going to go over the first challenge with you because there's 2 challenges within this activity, is that you're going to need the student handouts. The handouts are everything, especially for this first activity where you will be taking a look at this particular network and deciding which is the best route to take to hunt for the different items. And we're going to talk about that. But take a look at the materials. Very, very simple materials. You need those handouts. You know, you can use a dry erase board to help you kind of brainstorm some ideas, colored pencils, cotton swabs, or toothpicks, buttons or pennies, you know, things that you can find that will help you make this connection as you create your own spanning tree. So let's talk about networks in the real world. You know, there's all types of networks out here. We have phone networks. Okay. We have railroad networks to get you to different places. You know, I want you to kind of think about that. I don't want to say all of them because I would love for you to kind of in the chat box, if you can think of a network. You know, they're a part of our lives. I just talked about telephones, and I talked about railroad, like maybe transportation can get us from here to there. Any other ideas? If you have an idea of a network that's in your life that you use, you can put that in the chat box, and anyone can put that in the chat box. We'd love to hear your ideas about a different network that you may use. Okay. And while you guys are thinking about that, I see Miss Santra says Artemis missions. This is what she learned. Thank you. Artemis will land the first woman and the first person of color on the moon. And that there are 3 Artemis missions. Yes, yes. Thank you so much for your addition to what you learned, or what you learned about Artemis future missions. Thank you so much. So a little bit about networks. Your class schedule. If you're on a class schedule, like you're probably on a class schedule right now, that's an example of a network. A bus route. If you take a school bus and it goes here and there and pick up different students, that's a network. When you go to the grocery store, I know when I go to the grocery store, it's definitely a network for me because I know where I'm going to go here, then I'm going to go here. The shortest route to get through that store as quick as possible, right? So those are examples of a network. You can even have a friend network. Okay, maybe you're on social media and you have your network of friends that you conversate with about certain things, and so NASA's Deep Space Network is a lot more technically complex than your friend network, but these are all examples. And so here you have your challenge. This is your challenge. And before we go, I just want to make sure you understand your challenge. You're invited to a NASA center and you've been challenged to a scavenger hunt. Okay. The scavenger hunt consists of a list of items. You can see the items there that you will need to find quickly. You have to find these items quickly. And it's important for you to know that you have to take the fewest steps possible, okay? The fewest steps possible to locate all of the 10 items, okay? So here's your map. Here's your map that you see here. This is your diagram of all the 10 items. And then you see the little dashes, okay? Those dashes are connecting to each item. Each dash is a total of 20 steps. Okay. So what's your route to make sure you can connect and get to all of the 10 items? You're going to need a color pencil or a crayon on your sheet here because it's the same image. Okay. And you will create your pathway to locate all of those 10 items. You need, again, a color pencil or a crayon or a marker, and mark your map. Okay, you want to do this individually. Okay. And I'm talking to the teachers. You want to do this individually so you can have your own ideas first. And then educators partner them up, with the partner. And then they can share their ideas or their trajectory of how they, went about, gathering all of the 10 items. And then how many steps did they take? Remember, each dash is 20 steps. So here are your conditions. You have some conditions here. Like, you have to take a look at these. The first condition is you must connect all of the scavenger hunt items together with the path that you chose. So they must connect, okay, with your path. 2, you must take the least number of steps possible, okay? And you remember that each dash contains 20 steps. How do you get the student handout? Okay, I'm going to put the link to the educator guide in once more. And so you can grab it. Okay, give me a second. Give me 1 sec. And it's activity 4. I'm going to scroll down to activity 4, which is the last activity in this educator guide. Okay, activity 4, and you'll see the handout. And so, yes. And so once you're done with that, and we don't have time now because it is 10 o'clock, but I will love for you guys to post how many steps that you took. What was your strategy? You can even explain your strategy. Come back to the Padlet later, and tell us your strategy on how you were able to solve that scavenger hunt problem. Okay. Would love to know, and love to hear your ideas and your strategies. And so then you can also go on to the other activity. There's another, a second challenge as well. And again, it's all about networks and using those spanning trees. And educators, I know the kids will, get a real kick out of this. And so I so appreciate you guys. And I know you guys are on a schedule because that's a part of a network. And I know we are a little bit past our time, but what I'm going to do right now is I'm going to take us to a couple of places. First, I want to take us back to the lobby. I'm going to do that for because I would love to know if you did not get a chance to answer the poll questions. Would love to know what school you're representing. Would love to know, how many students joined in today. And again, I would love to have given you guys a shout out. I did give a shout out to El Senora in Puerto Rico. Welcome. Jean de Fatima in Rio de Janeiro. Wow, welcome. Hadi in Istanbul. Welcome. And if I'm butchering your names, I'm doing my best. I really am. And so if you have not already done so, to add those ideas, we'll love to hear it. And I also have the second poll question. I see we have some students, some parents. Welcome everybody. And so we do have, I do notice that we do have we have Deepika, and we also have Miss White, who are part of the Artemis Learning Pathway. I think Deepika, maybe she's not there. I'm still looking. Oh, okay. Miss White, I don't know if you want to say something. Dr. White, I don't know if you want to say anything to our participants today about Artemis Learning Pathways or anything. You are more than welcome to speak. Okay, great session. Thank you, Miss Dr. White. I did get an email earlier from a participant saying, "Oh, I missed some of the other Artemis Learning Pathway sessions. How can I, see them again, or will they come again, or can we get the resources?" We will be doing this again as the launch gets closer. We will be hosting these again. So you can spread the word, and also you can also email us. You can email me at latina.taylor@nasa.gov. I'm going to go to the closeout because I think I gave you guys some time to do that, where you can see some additional resources and notes and things as well. And if you don't have all the files, such as this PowerPoint, I'm going to go ahead and put this link in the chat box, and you can access additional resources. So thank you guys so much for coming. Thank you so much for your engagement. And again, if you have questions, please do not hesitate to ask. Thank you.